The following lesson is to demonstrate how to use the object's position to shade particular components or parameters in the render tree. In this example, I've created a cube that has a one soft-image unit in size, and placed it at the center of the world. Obviously, this XYZ position can be extracted in the render tree to be able to drive other shaders. So the way to do this is by going under the node menu under share and pick vector. Vector by the nature of a vector is simply a parameter that contains three parameters, three values, the x, y, and z. And this three components are carried over. Whenever you do a single connection, it will basically carry over these XYZ information automatically, so in a single connection. The share, in fact, any share shader actually here are simply a pass-through shader. Whatever the input value gets basically will be outputted by the shader, so it's really a pass-through shader. The reason why this shader is being used here is simply because we need to have a shader to be able to host the expression that we'll be putting on the actual vector share. Now, so let's connect this one directly on surface. So as you can see now, because I've connected a vector to a color port here, so the red lines here shows that it's a RGBA color connection. So automatically XSI or the render tree tool will insert this conversion shader. The vector to color simply map the X to red, the Y to green, and the Z to blue as a simple conversion without doing any sort of advanced math. So it's basically a one-to-one mapping. Obviously, if I do a draw region here, I'll get white because the actual value here are white. So if I put 0, I get a red color. So you see that the X is being mapped to red. Now if we put an actual expression on this parameter right here, we will be able, as the object moves, to change the actual color being given to the object. Okay, and that color is basically the same color over the surface of the object. So it's more like should be seen as a constant value for a given frame. So it's not something that varies over the surface of the object, but more like throughout the entire object surface. So it's really producing a constant color. Now let's put a simple expression. So let's go here and do a set expression. Let's go here and do expression editor. Now we have the actual shader here, so we're going to type .input.x, which is the actual parameter. Right now it has a constant value which is 0. So in this case, what I want to do is basically pick the object here and go and select the actual position. In this case, we want to pick the kinestate, which is same thing as the SRT of the object in a global space. So we'll take the position and pick X. Okay. Then we proceed to apply the expression. So the expression editor will tell you the expression is valid. Now we'll copy this here and basically go to the next, which is Y, and simply paste this value, replace the X with the Y, and do apply. Again, we'll do the same thing with Z. We'll go here, paste it, replace X with Z, and apply. Now I have an expression shader, so let's close this and reopen it. Now we have the equal sign, so it's driven by an expression. So if I do this, obviously I'll get 0 because the RGB is basically set to 0. If I slowly put a different position XYZ, obviously it will imprint a different color. So I could pretty much do this, for example. So red and green will create yellow. So now we have this expression, and and as you translate it, it will basically color it. Obviously, having a color range, an active range where the color will vary. In this case, it's basically limited to 0 and 1. Obviously, you want the object to vary color over maybe long distance. For example, probably 10 units or even 100 units. So one of the ways to actually resolve this problem is by using a vector mat node. So under mat, vector, you can actually take this information right here, put it into the vector input 1, and connect it to the other input here. So what we'll do here, we'll simply divide the input, or we'll actually we'll do a vector input 1 times the scalar input. So we'll say I want to multiply this by 0.5. So whatever comes in here will be multiplied by 0.5, which is the equivalent of doing a division by 2. And it's going to output this new value, extended value, to the shader. So as I do a rendered region here, this is black. If I put 0.5, then obviously it's not going to give a full 0.5 red, but actually it's more like it's going to be 0.25. So if I go back to 1, now I get a 50% red, and if I go to 2, now I get a 100%. So obviously I can actually, multiply this by divide it by 4 times, or multiply it by 0.25, and I'm going to extend the range of the of this expression without having to do some sort of advanced expression or anything like this. Now what we want to do is we would like to extend the range. So let's make it like 0.1. So 0.1 is the same thing as divided by 10. And what I'm going to do is start to extract very specific components of the vector. So for example, if I go under node and I do conversion, and I could say vector to scalar. So this vector to scalar allows to extract very specific components. So either x, either y, either z. In this case, x is going to return the new extended position position x, and this one is going to return y position and z position. In this case, I'll connect this one directly to the surface right here. So obviously we'll create a new node, which is a conversion node that will take this float value and convert it to RGBA. In this case, this value is directly copied to RGB as is. So it will give you a grayscale value in this case. So if I do render region and I put this thing to 0, I'll get black. If I get to let's say 0.5, I'll get a different gray. If I go for 10, for example, I'll just move the render region, I get white. And then if I get 5, I'll get a 50% gray. So as you can see here, I'm actually starting to extract very specific components of the vector element to be able to map it. Now what we really need to do here is it's really kind of interesting to be able to vary the actual color over as the object moves, but now what we want to do is having a gradient color modulating the actual object's color based on distance. So I'm going to discard the region and delete these particular shaders. Selecting the vector node and pressing delete will delete it. Voila. And I'm going to go under node and go under mixer and pick the gradient shader. This gradient shader is if I connect it directly to the surface, as it is right now, surface, voila, and I do render region, it will actually return a constant color. The way gradient works is that the input, which is here, this input will determine what is the actual lookup color over this gradient. So whenever the input is 0, it will return basically red. Whenever the actual input is 1, then obviously it will return yellow. If you go 50%, then you'll get this more like bluish color here. Let's say we go 50%. Now we get this color right here because that's pretty much where this 50% is located. The interesting aspect here is that this particular input can be driven by other shader. So if I connect this one right here and I connect it to the input, obviously as you can see now, because this is 5 and the actual position is going to give a 50% because we pretty much divided the actual position by 10. So if I go back to 0, I'll get red. If I go back to 1, I'll get to 10. I'm sorry, I'll get yellow. If I go 50%, which is 5, I'll get this new color. So as you animate it, you'll get a different color. So let's go back to 0 here, and let's select the actual SRT and press K key to save an animation on the position, because this is the marked parameters. Let's go to frame 100 and set 110 and press the K key to save a key on the actual position. So now we see that the actual element is being animated. We'll simply go back here and simply play back. So if we go 50%, then obviously as I change the timeline, I'm going to change the actual object's color over time. Well, this is the that concludes this lesson, and I invite you to watch the other lesson that will get into a little bit more technical information about how to take this and do advanced effects. So thank you.